Hello, my Algebra 2 students. What are we doing? Amplitude, frequency, and period. So all of that was mentioned in the notes yesterday, but we get to kind of mess around with it today. Before we do that, just starting with reviewing the basic sine and cosine graphs. For sine, what you need to know is that it hits 5 exact points from 0 to 2 pi, right? So get your notes out from yesterday if you need to. You can flip back and look. But for sine, it starts at 0 and ends at 0. So at 2 pi at 0. And dead center, it should be 0. So at pi at 0. At pi over 2, you're popping up to 1. At 3 pi over 2, drops down to -1. Those are those 5, I call them anchor points I want you to hit. So plot them first, and then make sure to go through the dots. So it needs to be a relatively accurate sketch. Same thing for this other one. For cosine, cosine starts and finishes at 1. So at 0, it's 1. It's 2 pi, it's 1. It's going to hit rock bottom, all right, at pi. So dead center, come all the way down, hit -1. Then it crosses the midline. So crosses the axis at pi over 2, 3 pi over 2. Then connect the dots. All right, that's going to be your cosine graph. For each of these guys, amplitude, that's just 1. That's that A value. The frequency, that's 1. That's the B value. It's the number of cycles you see from 0 to 2 pi. The period is 2 pi itself. That's the length of one cycle. All right, phase shift. There is not one. We're not shifting it left or right. The midline for both is the y-axis right now, or the line y equals 0. So this is the C, that's the D in the equation, okay? These two are the ones we're going to kind of mess with today, all right? So when we slide on up, that's the equation I was just referencing, when we have the whole A, B, and C, A, B, C, and D in there. All right, so we need our calculator to do this. Grab your calculator, and I really mean it. Don't just stare at mine. Get your calculator out, and I want you to type in to the y equals 2, and then sine of x. Now, your best screen to be able to do this on, is the window that we're required right here. So let's do it from 0 to 2 pi. So go to your window, and I want you to go from 0 to 2 pi. And now when you type in 2 pi, it is going to adjust to being 6 point whatever, because that's what 2 pi is equal to. For your scaling, mine's already set there, but I want you to put in pi over 2. So pi over 2 like that, and then it'll adjust to that. As for y min and max, you can leave them at -4 and 4. If yours aren't at -4 and 4, put them there. All right. All right, let's do it. So when I hit graph, excuse me, this is what we should be looking at. So if you take a look at the graph, it looks just like a regular old sine graph, but if I put in plain old sine of x, I think it's going to be a helpful little comparison here. So if I type in sine of x, that's my red graph. So that's what the typical sine curve would look like. The blue is what we just came up with. So it's just stretched taller and lower. So the amplitude, if I look, that's the 2 right there. In terms of the range then, that means it went from -2 to +2. All right, this next graph, we have y equals -3 sine of x. Let's put that in here and take a look. So don't hit zoom anything, just hit graph. All right, hopefully what we can see here, two things. It's stretched further, but it's also upside down. So let's do our best to sketch this here. So I'll slide this kind of out of the way. So it still starts at 0, still ends at 0, dead center at 0. But it's going to go down to -3 and then come up to +3. And now when you look at that amplitude, hopefully you're like, oh, I see it. I knew that was going to happen. So the only thing you want to keep in mind, it's very tempting to say the amplitude is -3. It is not. Amplitude is always positive. So think of it as the absolute value of that. And that would be our amplitude. So write yourself that little note that we always consider this to be positive. And then the range means it would go from -3 to 3. Okay, let's do one more. The next one's cosine though. So I'm going to take this out. I know you have above, geez Louise, a cosine graph. I'm going to put mine in here really quick just so I have it as reference. So there's our basic cosine graph. That's the one that we graphed up above on the top right. And now I'm going to put in 1/2. So I want you thinking, what do we think the 1/2 is going to do? And then take a look and see if that's what you expected. So hopefully you were expecting it to be a little squished because it's only half the height. So now, for my graph's sake, here's my little 1/2. There would be my little -1/2. I start and finish at 1/2. At the middle, at pi, it hits the bottom. At pi over 2 and 3 pi over 2, it hits the middle. So kind of looking a little bit like that. All right, that's because the amplitude is 1/2. And then the range went from -1/2 to +1/2. Okay, now without even drawing the sketch, you should be able to tell me what the amplitude is and what the range is for this last one. Right? But let's talk about conclusion-wise. The amplitude, it's always what we said, that vertical dilation. So essentially like a stretch or a compression. And then it's always positive. So what that means for us is if you have a -a, then there's also a reflection. And what the reflection would be is over the x-axis itself. As for the last piece, when the amplitude was 2, the range was -2 to 2. When the amplitude was 3, the range was -3 to 3. So the amplitude and the range are directly correlated there. All right. Next one. Let's talk about frequency and period. We're going back to our calculator here. Sine of x, just plain old sine of x first. Just to remind ourselves, okay, that's basic old sine. That's what it looks like. And now let's do sine of 2x. And hit graph. So the height is not changing, meaning the amplitude doesn't change. But what's changing is that number in front of x. And so that number in front of x, remember that's your b value or your frequency. So the frequency is 2. And when you look at it on the graph, you should be seeing 2 full sine curves there. So let's do our best to sketch that. So it starts at 0. It's hitting 0 at pi over 2. It's actually hitting 0 at pi. And again at 3 pi over 2, and then 2 pi. And then we're hitting top at 1, about halfway between, -1, halfway between here. And then same thing again, up and bottom. All right, connecting the dots. Look at our cute little graph there. All right, so a couple things. When the frequency is 2, We're seeing 2 full cycles there. Remind yourself, and I'll grab my pen to kind of highlight it. That is 1 cycle right there. And then the second one would be the one next to it, right here, that repeats. The period is the length of 1 cycle. So since the length is wherever you end minus wherever you started, look at that first red cycle. It's starting at 0, ending at pi. So if I do pi minus 0, then the period itself just is plain old pi. All right, as for the range, like we said, nothing changed there. So -1 to 1 is it. Okay, let's take a look at the next one. I'm going to leave basic old sine in there. I think it's helpful to see the comparison. So I'm going to get rid of this one and change it to 1/2 x. All right. So remember, the first one is basic old sine. The second one is sine of 1/2. All right. If you look, it sort of almost looks like a really wide parabola or something. But basically what you have is it's starting at 0. And at 2 pi, it's ending at 0. It's kind of going up and down from there. Where it's hitting the top point is dead center right there at pi. So you get this little arch like that. That's what the graph looks like. Well, how come? The frequency is 1/2. And what that actually means is we're only actually seeing half of the cycle, right? So to see the other half, meaning like the bottom, we'd have to keep going. All right, so what's the period then? Well, if you're only seeing half of it from 0 to 2 pi, to see the other half, we'd have to go all the way out to 4 pi. So this would be 4 pi here. As for the range, remember, if we kept going, it would drop down to -1. So it would still go -1 to 1. One more, but this time it does switch to cosine. So I'm going to put in plain old cosine. Remind ourselves what that looks like. So plain old cosine. There it is. Starts at 1, drops to -1, comes back up to 1. Right? It's like a little roller coaster. Okay. So if we compare that to cosine of 4x, let's type that in there. It's kind of cute, to be honest. But what's really happening is it's graphing 4 little cosine graphs for us. So it's going to start at 0 and it hits, or excuse me, start at 1 and it hits 1 again right here at that first tick mark. That's pi over 2. And then same thing, it drops down again, hits the top at that next little tick mark. So at every increment there at pi, 3 pi over 2, excuse me, and 2 pi, plot that point at the top. Halfway between is when it hits the bottom. So you're just kind of eyeballing this. Halfway between is midway through that little middle block here. So right here it would hit -1. Here it would hit -1 because everything is very symmetrical on these graphs. Where you're going to hit the axis, halfway between that. And then do your best to connect. Ooh, not my best graphing to date, but that's okay. All right, the frequency. Frequency was 4. That's the important part here. All right, what's the period? So the length of 1 cycle, just this, where it starts at the top, drops to the bottom, and comes back up. That is 1 teeny tiny little cycle. So the length of that little itty bitty cycle right there, it's done by pi over 2. So when we do end minus start, that's it. You're done right there. All right. And then the range. Still not changing, -1 to 1. Okay, we'll hold off on that last one for right now. In terms of the conclusion here, the frequency or the B value, remember it's the number of cycles from 0 to 2 pi that you'll end up seeing, right? So like that last one, there was 1, here was 2, here was 3. There's the fourth one, right? That's how many cycles that you should see. There is a little shortcut though, and that's to do with the period. So because the period is equal to the length of one cycle, and the length of one cycle is typically 2 pi, if you actually take 2 pi and divide it by the B value, that will give you what the period is. All right, let's do one practice one together. We'll save everything else for class. So slide it on down here. The very first one here, y equals 6 sine of 4x. So things that we know about this based on the equation. The A value is 6, which represents the amplitude. The B value, that's 4. That represents the frequency. Right, so visually, it's going to stretch all the way up and down to 6. Frequency-wise, I'm going to see 4 little cycles from 0 to 2 pi. So what else does that affect? That means the period is equal to 2 pi divided by that B value. And we're going to see each little cycle has a length of pi over 2. That's the period there. And then the range, because of that big old stretch, it's going to go all the way down to -6, all the way up to +6.